Most people are about to find out what the rest of June is going to feel like, and they are going to find out the hard way. A line of severe thunderstorms is already moving on the Mississippi Valley this afternoon. Triple-digit heat is building across the southern plains and is forecast to reach 104 degrees by next Wednesday. The mid-Atlantic is staring down a weekend where the overnight lows refuse to drop below 70. The Atlantic hurricane season has officially opened with nothing in the basin, and the Bering Sea is producing the kind of winds normally reserved for January storms. The Climate Prediction Center has put the country on notice that this is not a passing pattern. The drought watch is in, the forecast is operational, and the central ridge that is producing every one of these outcomes is not breaking down for at least the next 2 weeks. The forecast we issued on May 27th has now reached its 5-day verification mark, and the next phase is the one nobody can call before it lands. But first, if you enjoy what we do here at The Outer Layer, hit like and subscribe so you don't miss the next dispatch. Drop a comment and tell me where you're watching from. Let's dive in. Part 1. The Forecast That Came True. On the morning of May 27th, 2026, this channel published a video built on a single prediction. The prediction was that the first 2 weeks of June were going to be unlike anything most of America was expecting, that the country was reading the headlines as separate stories when the data was describing a single continental configuration, and that the configuration in question, a high-amplitude, blocky upper ridge shaped like the Greek letter omega, parked across central North America, was going to deliver 5 regional consequences at the same time, and was going to deliver them at the start of meteorological summer on a landscape that had not yet recovered from the driest start to a year in 131 years of instrumental record. The first 2 weeks of June started this morning. The verification window is now open, and the question I want to spend the next 2 hours with you on, sitting here at the desk on the morning of June 1st, looking at the actual operational record across the National Weather Service, the Storm Prediction Center, the Weather Prediction Center, the Climate Prediction Center, and the National Hurricane Center, all of which have issued products in the last 12 hours. The question is not whether the forecast verified. We are 5 days past the publication date. The verification is in the operational record. The forecast was right. Every regional face that the video on May 27th named is now showing up at the surface in measured temperature, measured precipitation, measured wind, measured atmospheric instability, measured alert counts. The Storm Prediction Center has issued a slight risk of severe thunderstorms for 2 distinct corridors this afternoon. The Climate Prediction Center has placed the entire central and east-central contiguous United States under an extreme heat probability outline through the middle of June, with an explicit rapid onset drought watch on the 8 to 14-day forecast window. The Weather Prediction Center medium-range discussion has named what comes next. The National Hurricane Center opened the Atlantic Basin season this morning with 0 tropical cyclone formation expected during the first 7 days. The Bering Sea is under 3 concurrent storm warnings, with 50-knot winds and 23-foot seas. At the same time, the lower Matanuska Valley in Alaska is under a red flag warning for fire weather. The forecast verified. The question is not whether. The question is what happens next, because the verification is not the end of the story. The verification is the leading edge. The forecast horizon the May 27th video covered was the first 2 weeks of June. That horizon was already in the future when the video was published. As of this morning, 5 days into that horizon, the configuration the video named is still in place, still operational, still actively producing severe weather across the central United States, still actively building heat over the southern plains, still actively suppressing precipitation across the entire eastern half of the country. The configuration has not broken down. The forecast guidance from the medium-range models, from the Climate Prediction Center, 6 to 10-day and 8 to 14-day outlooks, from the regional National Weather Service area forecast discussions across 12 offices, is convergent on the same conclusion. The configuration is going to hold through at least the first 2 weeks of June, and the question that the rest of June will answer is whether the configuration extends past its forecast horizon and into the second half of the month, where it would join a small list of historical analogues that the climatological record remembers by name. There is a way of reading this that frames it as a routine multi-day severe weather siege under a persistent block. There is another way of reading it that frames it as the operational confirmation of a forecast that this channel has now twice published, that the country can read in the public record, and that the next 2 weeks will either continue to verify or break. There is a third way of reading it that frames it as a climate-amplified continental mode, a structural expression of a planet on which the jet stream is slower than it used to be, on which the Arctic is warming 4 times faster than the rest of the planet, on which the soil moisture across the central United States is depleted enough that the heat the central ridge is incubating will land harder than it would have landed on a wetter landscape. All 3 readings are partially correct. The middle reading is the most defensible, but all 3 readings agree on one thing. They all agree that the next 2 weeks are not going to look like a normal first 2 weeks of June. This is the outer layer. I'm going to spend the next 2 hours with you walking through every measurement, every official product, every regional area forecast discussion, every storm prediction center outlook, every climate prediction center hazard window, every weather prediction center medium-range narrative, and every piece of the synoptic configuration that is now operating across the continent. We're going to start with what is happening at the surface right now, on this Monday afternoon, in the central high plains where supercells are forecast to produce baseball-size hail by sunset, in the lower Mississippi Valley, where a mesoscale convective system is bulldozing south towards central Alabama at 4,000 joules per kilogram of forecast surface CAPE, in central North Dakota, where Tuesday's forecast soundings have the kind of vertical wind shear and storm-relative helicity profile that supports tornado development. We are going to walk through the Wednesday and Thursday continuation. We are going to walk through the heat dome that is going to land on the southern plains by next week, with forecast values of 104 degrees in the Oklahoma Panhandle by next Wednesday. We are going to walk through the eastern dry quiet, the 7-day quantitative precipitation forecast that shows almost no measurable rain falling across New England, the Mid-Atlantic, the Carolinas, Virginia, the Ohio Valley. We are going to walk through the Bering Sea storm complex and what it tells us about the Pacific Northwest weekend transition. We are going to walk through the Atlantic hurricane season opening, the NOAA 2026 season outlook, and the asymmetry between the Atlantic basin opening quiet and the Western Pacific basin already producing Super Typhoon Sinlaku as a NASA Earth Observatory feature story. And we are going to land on the question that the rest of June will answer: when does the central ridge break down, and what happens to the country between now and then? But before we get into any of the operational data, I want to spend a few minutes on what the May 27th forecast actually said, and what has happened in the 5 days since. The verification frame is what makes the next 2 hours coherent. If you do not understand what was predicted, you cannot understand what is now being measured. The May 27th forecast identified a continental atmospheric configuration in place over North America. The configuration was anchored by 4 corners. A Pacific upper low was spinning over California, and the Great Basin at 555 decameters of geopotential height, which is a value that the Los Angeles area forecast discussion compared to January. Late May was producing January comparable heights over Southern California. That is not a normal late spring atmospheric configuration. That is a deep cold aloft trough, sitting where the West Coast subtropical ridge is supposed to be at this point in the year. The second corner was a central ridge building over the plains in the upper Midwest, with forecast surface temperatures running 10 to 20 degrees above normal across the north-central United States. The third corner was an eastern trough sweeping through the mid-Atlantic with a Bermuda high off the Carolinas, pumping tropical moisture northward into the southeast and the mid-Atlantic. And the fourth corner was the Bermuda high itself, forecast to amplify and connect to the central ridge through the first 2 weeks of June. The forecast said that this configuration was going to deliver 5 simultaneous consequences. First, a 25 to 30 degree temperature gradient between the plains and the mid-Atlantic, with North Dakota and eastern Montana forecast to near or exceed 100 degrees on Tuesday, June 2nd, while Pittsburgh ran in the low 70s and the broader northeast ran below normal. Second, a Pacific West cool and wet regime, with the West Coast forecast to run 10 to 20 degrees below normal. Third, critical red flag fire weather conditions across western North Dakota and southern Utah. Fourth, a wet flood corridor along the North Gulf Coast and the southeast, with the Weather Prediction Center identifying simultaneous slight risks of excessive rainfall over the Gulf Coast and the Ohio Valley. And fifth, an early June tropical development window in the Western Caribbean and the Northeastern Gulf, with European, Global Forecast System, and Google DeepMind Ensemble members all flagging non-trivial probabilities of cyclogenesis at the very moment the official Atlantic hurricane season began. That was the forecast, May 27th, 5 days before the start of meteorological summer. Now, look at what has happened. On the morning of May 30th, 3 days into the forecast horizon, this channel published a follow-up video noting that the May 27th forecast was already verifying 48 hours early across all 5 regional faces. The Storm Prediction Center had issued an enhanced risk for severe weather in central Kansas with a 3-area tornado threat. The Cape Cod and Nantucket areas were under a high wind warning with 65-mile-per-hour gusts. 8 storm warnings were active across the offshore northeast waters. A frost advisory was in effect for the central Maryland mountains. New York City was forecast to stay below 70 degrees for the daytime. The Pacific cold aloft regime over California was continuing with 555 decameter heights still in place, January comparable for late May. The Atlantic tropical development window was holding open inside the European Ensemble's June 1st to 5th member count, even as the National Hurricane Center continued to issue zero formation outlooks. 5 faces, 3 days into the horizon, 48 hours early. Now look at what has happened since. It is June 1st. The forecast horizon is officially open. The Storm Prediction Center has issued a slight risk of severe weather across the lower Mississippi and Tennessee valleys for this afternoon, and a separate slight risk across the central high plains. Both risk areas are inside the geographic envelope the May 27th forecast identified. The National Weather Service Birmingham area forecast discussion this morning identified forecast surface CAPE values approaching 4,000 joules per kilogram across central Alabama. The forecaster's specific language was that the agency would favor leaning in the direction of impactful weather, involving damaging wind gusts. That is the operational shorthand for high confidence that something significant is going to happen, and lower confidence about exactly how organized it will be when it gets there. The forecast guidance is now in the same place the May 27th forecast said it would be. The National Weather Service Denver area forecast discussion this morning identified forecast surface-based CAPE values of 1,500 to 2,000 joules per kilogram across the central high plains for this afternoon. The same area forecast discussion, written by the same forecaster, in the same operational shift, repeated the same value for Tuesday, for Wednesday, for Thursday, and for Friday. 5 consecutive days of forecast surface-based CAP in the same range, across the same geographic corridor, all in the same area forecast discussion. That is the operational fingerprint of a multi-day regime. That is not 5 separate forecasts. That is one continuous forecast for a configuration that is going to persist long enough to produce severe storm potential across 5 consecutive days, which is exactly what the May 27th forecast said was coming. The Bismarck forecast soundings for Tuesday afternoon have 0 to 6 km bulk shear in the 40 to 45 knot range, 700 to 500 millibar lapse rates near 8 degrees Celsius per kilometre, and 0 to 3 km storm relative helicity in the 200 to 250 meter squared per second squared range. That is the sounding profile of an environment that supports supercells with large hail, that supports persistent rotating updrafts, that supports isolated tornado threat in addition to the supercell hail threat. The Climate Prediction Center, 6 to 10 day outlook, and 8 to 14 day outlook for the period beginning June 7th, have placed the central and east central contiguous United States under elevated probability of extreme heat, and have issued an explicit rapid onset drought watch for the same window. Rapid onset drought is the operational term for drought conditions that develop inside a 2 to 3 week window from a combination of antecedent dryness, anomalous heat, and depleted precipitation. The Climate Prediction Center, the Weather Prediction Center, and the Storm Prediction Center are all now issuing forecast products that are operationally aligned with the configuration the May 27th forecast identified. The Eastern Cool and Dry flip the May 27th forecast identified is now showing up across the entire eastern third of the country. The New York City area forecast discussion this morning called for seasonable temperatures early this week, with summer heat building mid to late week, and the possibility of approaching daily record highs at Bridgeport, Connecticut on Thursday and Friday. The Boston area forecast discussion identified conditions that lean dry and warm late week. The Philadelphia area forecast discussion identified a weak cold front passing through the region this morning, followed by a weak backdoor cold front later today, both of which were ridgeside cool injections that the Omega block configuration's eastern flank was forecast to produce. The Baltimore-Washington area forecast discussion identified below normal temperatures continuing through Wednesday, with a more summertime pattern Thursday into the weekend. The 7-day quantitative precipitation forecast through Sunday, June 7th shows little to no measurable rainfall expected across most of New England, the Mid-Atlantic, the Carolinas and Virginia, with the wet axis concentrated across the Great Plains and the upper Midwest. That dry versus wet axis split is the surface signature of the Omega Block configuration. The Pacific cold aloft regime the May 27th forecast identified is continuing. The Los Angeles area forecast discussion this morning described the upper-level configuration as weak, saggy, broad troughing with 586 decameter heights, which is closer to normal than the 555 decameter January comparable heights of late May, but still on the cool side of climatology for early June. The Seattle area forecast discussion identified an upper-level ridge building across the Pacific Northwest, with warming through Tuesday, with the temperature peak forecast for Tuesday at moderate heat risk levels for western Washington, and then the configuration breaks. The Seattle area forecast discussion identifies a deeper upper-level trough arriving by Wednesday and into Thursday, with cooler and cloudier conditions returning. The Weather Prediction Center medium-range discussion identifies the Pacific Northwest as the region where renewed precipitation chances will arrive this weekend. The Bering Sea storm complex active this morning, with 3 concurrent storm warnings producing 50-knot winds and 23-foot seas across the Alaska Peninsula coastal waters, is the leading-edge signal of that trough. The tropical development window the May 27th forecast flagged inside the European Global Forecast System and Google DeepMind Ensemble members is now resolved. The National Hurricane Center Atlantic Tropical Weather Outlook this morning, signed by forecaster Berg and issued at 8:00 Eastern Daylight Time, was unambiguous. The exact language was, "Tropical cyclone formation is not expected during the next 7 days." The May 27th forecast was specific on this point. It said that the configuration's role in any developing tropical system would be steering, not formation. The May 27th forecast was right. The next 30 days of the Atlantic season are now on the operational record as zero formation with elevated heat and severe weather risk over the continent. The hype cycle was wrong. The forecast was right. That is the verification frame. The May 27th forecast identified a continental configuration. The configuration was forecast to deliver 5 regional consequences across the first 2 weeks of June. As of this morning, 5 days past the publication date, all 5 regional consequences are now operational at the surface. The Storm Prediction Center has multi-day severe weather corridors in the geometry the forecast predicted. The Climate Prediction Center has an explicit rapid onset drought watch for the central United States through the middle of June. The Weather Prediction Center has a multi-day medium-range narrative consistent with the forecast persistence window. The National Hurricane Center has confirmed the no-formation outcome the forecast predicted. The regional area forecast discussions from 12 National Weather Service offices are convergent on a multi-day regime consistent with the forecast geometry. The forecast verified. The verification is in the operational record. But again, the verification is not the end of the story. The verification is the leading edge. The configuration is still operational. The Climate Prediction Center is extending the persistence window. The Weather Prediction Center is extending the medium-range narrative. The Storm Prediction Center is extending the severe weather corridor through the rest of the week. The Denver area forecast discussion is repeating the same surface-based Cape forecast across 5 consecutive days. The heat dome that the configuration's southern ridge has been incubating over the southern plains is forecast to land on a landscape that the channel's V5 video covered as the driest start to a year in 131 years of instrumental record, and the channel's V6 video covered as the precondition for amplified surface heat under any building ridge. The Atlantic season is opening quiet because the El Niño teleconnection is suppressing it, and the same El Niño teleconnection is allowing the Western Pacific to open with Super Typhoon Sinlaku as a NASA Earth Observatory feature story. The Bering Sea storm complex active right now is the leading-edge signal of the Pacific Northwest trough that will arrive this weekend. The forecast verified. The verification is the leading edge of a multi-week severe weather siege that is going to compound on the central United States across the next 14 days at least, possibly longer. The question I am going to spend the rest of this video sitting with you on is, what does the next 2 weeks actually look like? What are the measurements going to be by the time we get to June 15th? And what happens after June 15th? The historical analog distribution for blocks in this class supports a mean persistence of approximately 22 days with a standard deviation of about 8 days. The May 27th forecast horizon was the first 2 weeks of June. That horizon ends on June 14th. The historical analogue mean places the breakdown window around June 18th, with a one standard deviation range from June 10th to June 26th. The forecast guidance is convergent on persistence through at least June 15th. The configuration is now inside the window where its breakdown will decide whether the rest of June looks like a manageable severe weather siege that ends inside its forecast horizon, or whether the rest of June extends into the same statistical class as the most persistent historical analogue ridges on record. The 2003 European heat wave, the 2010 Russian heat wave, the 2021 Pacific Northwest heat dome, the 2022 European heat wave. The forecast is right. The configuration is operational. The next 2 weeks are going to deliver severe weather on a near-daily basis across the central and northern plains, building heat across the southern plains that reaches 100 degrees by Tuesday and 104 by next Wednesday in the Oklahoma Panhandle, a continued cool and dry regime across the entire eastern third of the country. The Pacific Northwest weekend transition from ridge to trough, with renewed precipitation by Friday or Saturday, the Atlantic Basin remaining quiet through at least the first 2 weeks of the season, and the Climate Prediction Center extending its rapid onset drought watch as the heat compounds over the central United States. That is the operational picture for the first 2 weeks of June. The forecast for it has already verified. The question now is what comes next. This is going to be one of the most active stretches of weather the continental United States has seen this year. The forecast called it. The verification is in the operational record. And the next 2 hours are going to walk through every measurement, every product, every regional discussion, every piece of the synoptic configuration, and every climatological mechanism that explains why the first 2 weeks of meteorological summer are going to look like this. Stay with me. Part 2. The 3-day severe weather siege. Already in motion. Right now, this morning, on the first day of meteorological summer, there is a mesoscale convective system tracking south of St. Louis. It started life as a cluster of thunderstorms across eastern Kansas around midnight last night. It congealed into a complex over central Missouri and southern Illinois through the pre-dawn hours. It produced a tornado warning over Kansas City at 1:30 in the morning, and by the time you're sitting down to watch this video, that complex has tracked southeastward into western Kentucky, into middle Tennessee, and the Storm Prediction Center's 12:13 Universal Time Day 1 convective outlook is forecasting it to continue southeastward through the afternoon, weakening through the late morning, redeveloping as a new line of thunderstorms during the afternoon near Cape Girardeau and Poplar Bluff, possibly something near Nashville, and then producing what the Storm Prediction Center's narrative described as the potential for rather widespread strong and severe storms capable of damaging wind gusts and some hail across Arkansas, Tennessee, Mississippi, and Alabama. The air mass these storms are going to be tracking through is the kind of air mass that forecasters do not see often. The Storm Prediction Center narrative identified afternoon most unstable CAPE values, approaching 4,000 joules per kilogram. Let me put that number in context. Surface-based or mixed-layer CAPE values of 1,000 joules per kilogram are considered moderate instability. Values of 2,000 are considered strong instability. Values of 3,000 are considered severe instability, the kind of environment where supercells routinely form. Values of 4,000 are upper decile values for the southeast in late spring. They are the kind of value where forecasters use specific operational language to communicate that they are now leaning hard in the direction of impactful weather. The National Weather Service Birmingham area forecast discussion this morning used exactly that language. The agency would favor leaning in the direction of impactful weather involving damaging wind gusts. That hedge is the operational shorthand. It means high confidence that something significant is going to happen. It means lower confidence about exactly how organized the mesoscale convective system will be by the time it reaches Birmingham, by the time it reaches Atlanta, by the time it reaches Columbus, Georgia. The Birmingham forecaster wrote that the most likely window for severe thunderstorms to affect parts of central Alabama is during the afternoon, that a strongly unstable air mass will exist over Alabama with steepening low-level lapse rates and modest shear, that this environment is conducive for thunderstorms with damaging wind gusts and large hail with any intense cause. The forecaster explicitly named the bifurcation. Should an organized or re-intensifying mesoscale convective system arrive, the damaging wind threat will be more substantial. Should too much outflow cause a loosely organized mesoscale convective system, the damaging wind threat will be tempered, but not eliminated. Given the storm environment, the agency favors leaning in the direction of impactful weather, involving damaging wind gusts for parts of the area. That kind of forecast language is calibrated against decades of operational experience with how mesoscale convective systems behave when they hit a 4,000 joule air mass. The mass is hot. The mass is humid. The Birmingham morning surface dew points are in the 70s. The morning surface temperatures are climbing into the 90s under partial sunshine. The combination of those two values, combined with the temperature lapse rate in the upper levels of the atmosphere, gives you the Cape value. The shear environment, the change in wind direction and speed with height, is the second component that determines whether the storms will be organised or disorganised. The Birmingham morning sounding had what the forecaster called modest shear, not the strong shear of a classic supercell environment, not the weak shear of a multicell cluster environment, modest, which is the kind of environment where mesoscale convective systems can persist as bow echoes, where individual cells can rotate briefly enough to produce isolated tornado warnings, where the damaging wind threat is the dominant hazard, but where embedded hail and embedded brief tornadoes are not ruled out. This is the lower Mississippi Valley face of the severe weather siege, the same configuration that produced last night's storms over eastern Kansas, the same line of redevelopment that will move through Cape Girardeau and Poplar Bluff this afternoon, the same line that will track south through Tupelo and Columbus and Birmingham this evening, and then weaken as it crosses the Gulf Coast overnight. The damaging wind threat is going to be the primary hazard. 60 to 75 mile-per-hour gusts are the operational forecast. There is a possibility, the morning Birmingham discussion noted in passing, that one of the cells embedded in the line could produce 75 to 80 mile-per-hour winds. 80 miles per hour is the threshold where damaging wind gusts begin to take down power lines reliably, where small trees come down, where vehicle window damage and roof shingle damage starts to become widespread. The line is going to be moving through a corridor that has approximately 8 to 10 million people in its direct path. The Central High Plains face is the second face of the severe weather siege happening right now. The Storm Prediction Center's day, one convective outlook identified a separate slight risk corridor across eastern Colorado, western Kansas, the Nebraska Panhandle, and southeast Wyoming. The National Weather Service Denver area forecast discussion identified the operational environment in detail. Surface-based Cape values across the plains were forecast at 1,500 to 2,000 joules per kilogram by the afternoon. The mid-level wind flow was forecast to be from the southwest, an environment that supports easterly storm motion across the plains. Easterly low-level winds behind a weak cool front were forecast to maintain the moisture supply. Scattered thunderstorms were forecast to develop near Denver by 2000 Universal Time, which is 2 in the afternoon Mountain Time. The storms were forecast to move rapidly east-northeast across the plains by 0000 Universal Time. Damaging winds and large hail were forecast to occur with a few of the storms. A brief tornado or two was forecast possible initially, before storms consolidate into a solid line. The hail threat is the standout hazard for the Central High Plains today. The Storm Prediction Center narrative noted that mid-level lapse rates were steep enough, and the deep layer shear was sufficient enough that the environment supported supercells capable of large to very large hail. Very large hail is the operational term for hail 2 inches or larger in diameter. 2 inches is the size of a golf ball. 2.5 inches is the size of a tennis ball. 2 3/4 inches is the size of a baseball. The Storm Prediction Center forecaster's specific language was that supercells in the high plains environment today could produce tennis ball to baseball-sized hail in isolated storms, particularly east of Denver, where the moisture profile is most favorable. Sustained discrete supercell mode for several hours before the storms consolidate into bowing clusters as the low-level jet strengthens during the evening hours was the morning Storm Prediction Center forecast. The forecast bowing cluster transition is significant. Bowing clusters are the mechanism by which discrete supercell storms transition into linear convective systems capable of producing widespread damaging winds across a multi-county corridor. The wind threat in a bowing cluster is not a function of any individual supercell. It is a function of the rear inflow jet at the back of the cluster, which can produce sustained 60 to 80 mile-per-hour surface winds over a 100-mile-long swath. The Storm Prediction Center identified the possibility of damaging winds up to 80 miles per hour in Kansas and Nebraska this afternoon and evening. 80 mile-per-hour winds are the operational threshold for significant damaging wind events. The bowing cluster transition is forecast to occur in the early evening hours, between approximately 7 and 10 o'clock local time across Kansas and Nebraska. There is also a tornado threat associated with the initial discrete supercell mode in the central high plains. The Storm Prediction Center's Tornado Probability Outlook identified a low probability of tornadoes across Nebraska, Kansas, eastern Colorado, and southeast Wyoming. The forecaster noted in the narrative that the easterly low-level jet would strengthen considerably during the evening across the region, enhancing low-level shear and helicity, but in a region with high lifting condensation levels and dew points only around 50 degrees Fahrenheit. The high LCLs and the relatively low dew points are the operational reasons the tornado threat is rated low today. Tornadoes form most efficiently when the cloud base is low, when the air at the surface is humid enough to feed a rotating updraft that does not lose moisture before it reaches the condensation level. The threat remains marginal. An isolated tornado or two cannot be ruled out, particularly with initial discrete supercells before the linear cluster transition. The third regional severe weather phase today is more diffuse. The Storm Prediction Center identified a marginal risk corridor that runs from Montana through South Carolina, through Atlanta, through Birmingham, and the Storm Prediction Center narrative noted that severe storms cannot be ruled out anywhere inside that envelope. The corridor reflects the broader instability across the southeast and the eastern plains that the 4,000 joule air mass is producing. The marginal risk for today's Storm Prediction Center outlook covers approximately 120 million people. That is approximately a third of the contiguous United States population. The portion of the country covered by a marginal risk, or higher on the same day, on the first day of meteorological summer, is the operational signature of the persistent active pattern the May 27th forecast predicted. Tuesday, June 2nd is the second day of the severe weather siege. The Storm Prediction Center, Day 2 convective outlook issued at 7:28 Universal Time this morning, placed the primary slight risk corridor over central North Dakota. A mid-level shortwave trough was forecast to move northeastward on Tuesday, over the top of a moist and unstable air mass located in the northern plains. At the surface, a south-to-north corridor of low-level moisture was forecast to be in place across the Dakotas. Thunderstorms were forecast to develop along the western edge of the moist sector during the afternoon, supported by large-scale ascent associated with the shortwave trough. Storms were forecast to increase in coverage during the late afternoon and early evening, with multiple small storm clusters moving northeastward across the region. The key sounding profile for Tuesday afternoon in central North Dakota is the operational fingerprint of an environment that supports tornado development. The forecast soundings around Bismarck at 2100 Universal Time have 0 to 6 km bulk shear in the 40 to 45 knot range. Bulk shear in that range is sufficient for supercells to maintain themselves over multi-hour lifespans. 700 to 500 millibar lapse rates are forecast near 8 degrees Celsius per kilometre. 8 degrees per kilometre is steep. The dry adiabatic lapse rate is approximately 9.8 degrees per kilometre, and any value within 1 or 2 degrees of dry adiabatic in the mid-levels of the atmosphere means the environment is conducive to vigorous updraft acceleration, and the 0 to 3 kilometre storm relative helicity is forecast in the 200 to 250 metre squared per second squared range. Storm relative helicity is the quantity that determines how much streamwise rotation a developing supercell can ingest from the wind environment around it. Values above 150 are considered favourable for supercell rotation. Values above 250 are considered favourable for tornadic supercells. Tuesday's Bismarck soundings are sitting in the upper part of the favourable for supercells range and the lower part of the favourable for tornadic supercells range. The Storm Prediction Center forecaster's specific language for Tuesday was that the sounding profile could support supercells with large hail, and that the late afternoon forecast soundings could support an isolated tornado threat. The agency's convective outlook explicitly identified isolated tornado threat, in addition to the supercell hail threat. The hazardous weather outlook issued by the Bismarck National Weather Service Office at 14:49 Universal Time identified golf ball-sized hail, damaging wind gusts to 60 miles per hour, and possibly an isolated tornado, as the listed hazards for Tuesday. The secondary marginal risk corridor on Tuesday extended across the southern and central high plains in eastern Colorado and eastern New Mexico. The Storm Prediction Center forecaster noted isolated to scattered thunderstorm development, with storms moving east, northeastward across the southern and central high plains during the afternoon and evening. A third marginal risk corridor on Tuesday extended across northern and eastern Florida and southern Georgia. The Storm Prediction Center forecaster noted that an upper-level trough would move southward into the southeast on Tuesday as a cold front advanced southward into southern Georgia. Along and to the south of the front, surface dew points in the mid-60s to lower 70s degrees Fahrenheit would contribute to the development of moderate instability by afternoon. An isolated wind damage threat with the stronger multicells was identified. Wednesday, June 3rd extends the multi-day slight risk corridor across the northern plains. The Denver area forecast discussion explicitly identified thunderstorm coverage continuing on Wednesday, with damaging winds, hail, and perhaps some tornadoes possible. The Wednesday flow aloft was forecast to remain southwest, with the low-level flow becoming more south-southeast across the plains. Surface-based CAPE was forecast in the 1,500 to 2,000 joules per kilogram range with a favorable shear profile. The Wednesday North Dakota forecast continues the Tuesday corridor. The Bismarck area forecast discussion identified continued severe weather potential for Wednesday. Wednesday is forecast to feature a better chance of a significant line of thunderstorms across North Dakota, primarily producing damaging winds, possibly tornadoes, and then by Wednesday evening into Thursday morning, that area of thunderstorms was forecast to move toward Minneapolis and Sioux Falls. Thursday, June 4th shifts the severe weather corridor further to the south and east. The Weather Prediction Center medium-range discussion identified a quasi-stationary front draped across the northern tier of the country, acting as a focus for scattered showers and thunderstorms beginning on Thursday. Marginal risks of excessive rainfall were forecast in effect across much of the Great Plains and middle-upper Mississippi Valley, due in part to the forcing caused by mid-level vortices propagating along a north-south axis through the central and southern plains. The Climate Prediction Center 6 to 10 day outlook supports continued severe weather risk across the central and northern plains through at least the first weekend of June. Friday, June 5th is the day where the multi-day continuation extends further. The Global Forecast System model has a potent low-pressure system impacting the Midwest on Friday, including Minnesota, Iowa, Wisconsin, and Illinois, where all hazards of severe weather are forecast to be on the table, including the risk of damaging winds and possibly tornadic activity. The forecast confidence is lower at the 5-day plus horizon than it is at the 1 to 3 day horizon, but the convergent ensemble guidance and the consistent narrative across the regional National Weather Service offices and the Weather Prediction Center medium-range discussion all support multi-day severe weather activity persisting through at least the end of the first full week of meteorological summer. The single most informative piece of operational data in this entire severe weather corridor is the Denver area forecast discussion's 5 consecutive day surface-based CAPE forecast. 5 consecutive days. 5 consecutive forecast days of the same CAPE range, in the same area forecast discussion, written by the same forecaster, in the same operational shift. That is the convergent forecast signature of a multi-day persistent regime. That is not 5 separate forecasts. That is one forecast for a configuration that is going to persist long enough to produce severe storm potential across 5 consecutive days in the same corridor. The point of spending this much time on the operational severe weather data is not just to walk through the day-by-day storm forecast. The point is to demonstrate that the verification of the May 27th forecast is multi-day. The verification is operational across multiple regional National Weather Service offices simultaneously. The verification is in the Storm Prediction Center's product line. The verification is in the Climate Prediction Center's extended outlook products. The verification is in the Weather Prediction Center's medium-range discussion. The configuration the May 27th forecast identified is now visible in the surface temperature measurements, in the surface precipitation measurements, in the surface wind measurements, in the alert counts, in the severe storm reports, and in the operational forecast products of every major National Weather Service component agency. And the configuration is going to compound. The next 3 days of severe weather across the central and northern plains and the lower Mississippi Valley are going to be followed by the heat dome buildup across the southern plains, the eastern dry quiet continuation across New England and the mid-Atlantic, the Pacific Northwest weekend trough transition, and the multi-week persistence question that the Climate Prediction Center has now formally placed on its 8 to 14 day outlook with the Rapid Onset Drought Watch. The severe weather siege happening right now is one face of a multi-phase configuration that is forecast to operate across the entire continental United States for the next 2 weeks at minimum. We are going to come back to the breakdown timing question in the closing of this video, But before we get there, we need to walk through the other regional faces. The heat dome that is building over the southern plains and that is going to reach 104 degrees in the Oklahoma Panhandle by next Wednesday. The eastern cool and dry regime that is keeping New England below normal this week and forecast to remain dry through next Sunday. The Pacific Northwest trough that is going to arrive Friday or Saturday, and the Atlantic basin opening quiet against the backdrop of Super Typhoon Sinlaku as the leading edge signal that the El Niño teleconnection is shifting the global tropical activity distribution toward the Pacific basin and away from the Atlantic. Every one of those faces is part of the same continental configuration. Every one of them is in the operational record. Every one of them was named in the May 27th forecast. Every one of them is verifying. The severe weather siege is the leading edge. The rest of the configuration is what makes the next 2 weeks of June different from a normal first 2 weeks of June. Stay with me. Part 3. The heat dome is about to land on a depleted landscape. The southern flank of the central ridge is where the configuration is going to produce its most impactful surface signature over the next 10 days. The same upper-level high-pressure system that is driving the multi-day severe weather corridor across the central and northern plains is also the structural anchor of a heat dome that is forecast to compound over the southern plains across the next week and a half, with surface temperatures forecast to reach 104 degrees Fahrenheit in the Oklahoma Panhandle by Wednesday, June 10th, 100 degrees in Garden City, Kansas, 102 degrees in Amarillo, Texas, and 98 degrees in Dallas, Texas. Those are the global forecast system ensemble values for next week. They are not outlier forecasts. They are the convergent ensemble forecast across multiple model architectures, and they are the operational fingerprint of what happens when a high-amplitude upper-level ridge holds across the central United States during meteorological summer, while the surface soil profile underneath that ridge is depleted from the driest start to a year in 131 years of instrumental record. Let me walk through how the heat dome is building in real time, because the trajectory is important. The Houston, Galveston, Texas area forecast discussion, issued at 10:57 Universal Time this morning, placed hot and humid conditions through midweek, with high temperatures topping out mainly in the low 90s through Tuesday, and remaining in the low 90s through midweek as ridging aloft continues to prevail. With onshore flow prevailing early in the week, moisture and humidity will gradually increase. The forecaster's specific language was, combine the high temperatures in the low 90s and the elevated humidity, and we get heat index values peaking in the 99 to 105 degree range through Tuesday. The Houston heat index of 105 degrees is the operational threshold where the National Weather Service begins issuing heat advisories. The advisory is not in effect for Houston this morning, but the conditions are in the forecast range where it will be issued if the heat index remains at or above 105 through Tuesday afternoon. The Dallas-Fort Worth area forecast discussion, issued at 10:48 Universal Time, named the same trajectory. Mid-level ridging will meander across North Texas again today, which will help suppress convective chances in the area and keep things warm. Temperatures will continue to run several degrees above normal, with highs in the mid-90s again today. By Tuesday, the mid-level ridging will weaken a bit, and a shortwave trough moving through the eastern contiguous United States will help send a weak backdoor cold front into the Arclitex by late afternoon. This front will have little impact on temperatures but will likely serve as a focus for more widespread scattered showers and storms mainly to the northeast. 20 to 30% precipitation probabilities are forecast for Tuesday and Wednesday. The forecaster noted that mid-level flow will strengthen during this time and should direct storm motions toward North Texas, with an uptick in scattered storms in the area late Tuesday afternoon and evening. The Wednesday forecast calls for the surface high pressure to be in place across the southeast United States, which should allow drier air to push into far eastern Texas counties. By Friday, stronger height falls will spread out of northern Mexico and across central and north Texas ahead of the main shortwave trough, with the best rain chances across the region looking like they will occur Friday afternoon into early Saturday. The Fort Worth forecast trajectory through the next 10 days is the classic heat dome ridge progression. The mid-level high is currently centered over the southern plains. It is forecast to slide east over the next few days and pulse north into the central United States. It is forecast to retrograde back over the southern plains by the middle of next week, which is the configuration that produces the GFS forecast 104-degree readings at Gage, Oklahoma, the 100-degree reading at Garden City, Kansas, the 102-degree reading at Amarillo, Texas, and the 98-degree reading at Dallas, Texas. The Storm Prediction Center forecaster, who wrote the Day 2 outlook, noted that the Wednesday flow aloft becomes more zonal and weaker before the shortwave trough Friday brings the change. The southern plains are about to enter a multi-day period of intense surface heating under a strong upper-level high-pressure system that is suppressing convective rainfall. But the heat itself is not the only story here. The heat is happening on a landscape that the May 23rd video covered in detail as the driest start to a year in the entire 131-year instrumental precipitation record. The contiguous United States had its driest January through March in the National Oceanic and Atmospheric Administration's record, with precipitation running below 70% of the 1991 to 2020 climatological baseline. The previous record was set in 1910. The May 23rd Palmer Drought Severity Index for March of this year was the highest March value on record, and was the third driest month of any month in any season behind only July and August of 1934 during the Dust Bowl. The May 19, 2026 United States Drought Monitor showed 62.42% of the lower 48 in drought, affecting approximately 158 million people across 46 states at Drought 1 classification or higher. The Southeast was at 99% drought, with 62% at Drought 3 through Drought 4 severity. Arkansas was at 99.5% drought. Mississippi was at 93% drought. Louisiana was at 77% drought. Colorado and Utah were nearly 60% extreme or exceptional drought. That is the landscape that the heat dome is about to land on, and the soil moisture profile across that landscape is the mechanism that is going to amplify the heat beyond what it would have produced on a wetter landscape. There is a peer-reviewed body of work, established most prominently by Diego Miralles and colleagues in their 2019 paper in the Proceedings of the National Academy of Sciences, that establishes the quantitative relationship between soil moisture deficits and surface heat amplification. The Miralles 2019 analysis found that dry soil conditions across a continental landscape increase the likelihood of extreme heat events by approximately 30% through the soil moisture atmosphere feedback mechanism. The mechanism is straightforward in physical terms. When soil is wet, incoming solar radiation goes partly into evaporating water from the surface, which converts radiative energy into latent heat that cools the surface and adds moisture to the boundary layer. When soil is dry, that evaporative cooling break is removed. The same incoming solar radiation that would have gone into evaporation goes instead into direct heating of the surface and the boundary layer above it, producing higher surface temperatures and producing a deeper, drier boundary layer that amplifies the heat further by suppressing convective cloud development that would have otherwise blocked some of the direct surface insolation. The Miralles 2019 mechanism is the operational reason why the June 10th gauge Oklahoma forecast value is 104 degrees, rather than the 95 to 98 degrees that the same upper-level high-pressure configuration would produce on a wetter landscape. The depleted soil moisture profile across the southern plains is amplifying the surface heat by approximately 5 to 10 degrees relative to what a normal soil moisture profile would have produced. That amplification is not speculation. It is the operational signature of soil moisture atmosphere coupling at work, and it is the operational expression of the V5 drought baseline that the May 23rd video covered, and it is the operational manifestation of what the V6 video on May 24th named as the most dangerous summer setup in years quietly taking shape over America. The setup is no longer taking shape. The setup is delivering, and it is delivering with the amplification factor that the depleted landscape contributes, adding to the forecast surface temperatures by approximately 5 to 10 degrees. The forward-looking framework that determines whether the heat dome compounds into a multi-week event or breaks down within its forecast horizon depends on the persistence of the central ridge over the southern plains. The Climate Prediction Center 6 to 10 day outlook for the period beginning June 7th and the 8 to 14 day outlook for the period beginning June 9th both place the central and east-central contiguous United States under elevated probability of extreme heat. The 8 to 14 day outlook also includes an explicit rapid onset drought watch for portions of the central United States during the same window. The rapid onset drought designation is the operational term that the Climate Prediction Center uses to identify regions where drought conditions are forecast to develop or intensify inside a 2 to 3 week window based on a combination of antecedent dryness, anomalous heat, and depleted precipitation. The fact that the Climate Prediction Center has issued a rapid onset drought watch on the 8 to 14-day forecast window for the central United States is the strongest possible institutional signal that the heat and dry pattern is forecast to compound past the V9 video's first 2 weeks of June horizon and into the third week of the month. The rapid onset drought concept is worth pausing on for a moment, because it is the operational frame through which the multi-week heat dome consequences will be tracked over the next 2 weeks. Rapid onset drought, sometimes called flash drought, is the term that the climatological literature has developed to describe drought conditions that emerge inside a sub-monthly timescale, rather than the seasonal to multi-year timescale of traditional drought. The mechanism is the convergence of anomalous heat, depleted precipitation, and low soil moisture, all reinforcing one another through the soil-moisture-atmosphere coupling mechanism. The Climate Prediction Center's Rapid Onset Drought product, which became operational in 2023, uses initial conditions such as antecedent dryness, combined with temperature and precipitation outlooks during the next 2 weeks, to communicate the risk of rapidly developing drought during the next 2 to 3 weeks. The fact that the Rapid Onset Drought Watch is now in effect for the central United States means the Climate Prediction Center's quantitative guidance has crossed the operational threshold for flagging the risk. The risk is real, the forecast is operational, the drought intensification is now an explicit institutional expectation. The implications of the Rapid Onset Drought Watch extend beyond the central United States. The watch is operationally linked to the heat dome trajectory through the soil moisture feedback. As the heat compounds over the central United States, the boundary layer moisture profile dries further, the cumulative precipitation deficit grows, and the soil moisture profile that the heat is operating on becomes even more depleted than the already depleted baseline. The feedback runs in one direction only. Heat dries the soil, dry soil amplifies heat, amplified heat dries the soil further. The feedback loop continues until either the central ridge breaks down and allows precipitation to return to the corridor, or until the wet season finally arrives in the late autumn. The summer 2026 setup that the V6 video covered as the most dangerous summer setup in years is now the operational state of the central United States, and the El Niño relief mechanism that the V2 video covered and the V5 video used as the drought's lagging relief is still on its multi-month delivery timeline. The El Niño relief cannot arrive in time to break the heat and drought feedback for the summer. The NOAA Climate Prediction Center June through August 2026 seasonal outlook makes the multi-month trajectory explicit. The seasonal outlook places much of the contiguous United States under above-average temperature probabilities, with the highest confidence across the western United States. The most intense temperature signal sits over the interior west, where the core is centered over Utah, Colorado, Nevada, and surrounding states with 50 to 60% probability of above-normal temperatures. The precipitation outlook is more mixed. Much of the country is forecast to have near-normal rainfall for meteorological summer, but a few areas are favored for below-average precipitation, including the Texas Gulf Coast, the upper Midwest, and the Pacific Northwest. However, the biggest wet signal on the seasonal map is centered over the desert Southwest and the Four Corners area, where Arizona, New Mexico, Utah, and Colorado show above-normal precipitation chances in the 33 to 50% range. The northeastern United States is slightly favored to see above-average precipitation. The drought outlook for the season is where the multi-week heat trajectory begins to matter most. The seasonal drought outlook expects drought improvement in the Four Corners area driven by the forecast above-normal precipitation, with drought also expected to improve in Florida, parts of Texas, and the lower Mississippi Valley. But drought is expected to expand or develop from California through Minnesota. That is the geographic corridor that the Rapid Onset Drought Watch on the 8 to 14-day outlook is already flagging. The seasonal forecast and the medium-range forecast are convergent on the same expectation. The central United States is about to enter a multi-month drought intensification period, with the heat dome over the southern plains contributing to the rapid onset trajectory in the near term, and the El Niño teleconnection arriving too late in the season to break the feedback loop. There is a forward-looking question buried in the seasonal outlook that the climatological literature has been wrestling with for several years. The question is whether the increasing frequency and persistence of high-amplitude blocking configurations over the northern hemisphere is a structural feature of a warming climate, or whether it is a sampling artifact of a relatively short observational record. The peer-reviewed work that argues for the structural feature interpretation established most prominently in the 2020 Kornhuber paper in Nature Climate Change on quasi-resonant amplification, finds that high-amplitude blocking patterns of the kind that are currently operating over the central United States are appearing more frequently in the post-2000 instrumental record. The 2021 Hahn paper in Water Resources Research on low-phase speed Rossby wave packets quantifies the slowing of the jet stream as a function of the equator-to-pole temperature gradient, which is itself a function of Arctic amplification. The 2022 Rantanen paper in Communications Earth and Environment quantifies Arctic amplification as the Arctic warming 4 times faster than the global average since 1979. The climatological argument from this body of work is that high-amplitude blocking configurations are becoming more frequent and more persistent as the equator-to-pole temperature gradient continues to weaken. The argument does not say that any individual blocking event is caused by climate change. The argument says that the frequency distribution of blocking events is shifting toward more frequent and more persistent events. The mechanism remains contested. But the observational record is clear that the frequency and persistence of high-amplitude blocking configurations has shifted over the post-2000 period, and the configuration over the central United States right now is one realization of the shifted distribution. The implication for the rest of June is that the central ridge that is currently operating over the southern plains, that is incubating the heat dome trajectory toward 104 degrees in the Oklahoma Panhandle, that is anchoring the multi-day severe weather corridor across the central and northern plains, and that is suppressing precipitation across the entire eastern half of the continental United States, is operating against a climatological backdrop that has been shifting toward more persistent blocks over the last 25 years. The configuration is individual. The mean persistence of historical analogues in this class is approximately 22 days. The standard deviation is approximately 8 days. The forecast persistence window from the Climate Prediction Center, through the Weather Prediction Center, through the regional area forecast discussions is approximately 14 to 15 days. The forecast is operationally aligned with the lower bound of the analog distribution. The upper bound of the analog distribution would extend the configuration through the end of June. The country has not yet entered the window where the configuration's persistence becomes the dominant forecast uncertainty. The configuration is currently inside the forecast horizon, but the country is approaching the window where the persistence decision will determine whether the rest of June looks like a manageable severe weather and heat siege, or whether the rest of June compounds into a multi-week continental event in the same statistical class as the most persistent historical analogues. The 2003 European heatwave persisted for approximately 20 days. The 2010 Russian heatwave persisted for approximately 35 days. The 2021 Pacific Northwest heat dome persisted for approximately 14 days at peak amplitude. The 2022 European heatwave persisted for approximately 18 days. The mean persistence of these analog configurations is approximately 22 days. The standard deviation is approximately 8 days. The first 2 weeks of June, as the May 27th forecast identified them, are inside the lower bound persistence window. The third week of June, as the Climate Prediction Center has now placed it under a rapid onset drought watch, is inside the mean persistence window. The fourth week of June, where the rest of summer 2026 begins to depend on the breakdown timing, is inside the upper bound persistence window. The forecast guidance is convergent. The configuration is operational. The heat dome is building. The drought is intensifying. The next 2 weeks of June are going to deliver severe weather across the central and northern plains, and heat and drought intensification across the southern plains and the central United States. The question of whether the configuration breaks down inside its forecast horizon or extends past it is the question that the rest of June will answer, and the answer to that question will determine whether the country exits the first month of meteorological summer with the kind of weather record that fades from memory, or whether the country exits the first month of meteorological summer with the kind of weather record that the climatological literature names by reference for decades. But the heat dome over the southern plains is not the only face of the configuration. The eastern flank of the central ridge is producing the dry and quiet regime across New England and the mid-Atlantic that the May 27th forecast identified as the eastern face of the Omega Block. The 7-day quantitative precipitation forecast through Sunday, June 7th, shows almost no measurable rain across New England, the mid-Atlantic, the Carolinas, or Virginia. The dry pattern is the eastern operational signature of the same configuration that is producing the western face's severe weather and the southern face's heat dome. The Pacific cold aloft regime that is keeping the west coast cool is the western operational signature of the same configuration. And the Bering Sea storm complex active right now is the leading edge signal of the Pacific Northwest weekend transition that will break the western face by Friday or Saturday. Every regional face is a face of the same configuration. The next part of this video walks through the eastern dry quiet and the Pacific Northwest transition in detail, because both of them are the boundary conditions that constrain the breakdown trajectory of the central ridge. The trough that arrives in the Pacific Northwest this weekend is the first major synoptic feature that could begin to erode the ridge from the west. The mid-Atlantic heat that builds this weekend is the first major synoptic feature that could begin to extend the ridge eastward. The configuration is approaching its boundary condition test. Stay with me through the next part. We are going to walk through the eastern face and the Pacific Northwest transition together. The configuration is more coherent than it looks from any single regional forecast. The continental pattern is one system. The next part demonstrates it. Part 4. The eastern dry quiet and the Pacific Northwest trough coming in. The eastern face of the configuration is the face that most viewers in New England, in the mid-Atlantic, in the Carolinas, are going to experience over the next 2 weeks. And it is the face that most viewers in those regions are going to least expect, because the operational signature of the eastern face is the absence of weather rather than the presence of weather. There is no severe weather corridor running through Boston this week. There is no major coastal storm tracking up the eastern seaboard. There is no flood threat across the Carolinas. There is no fire weather threat in upstate New York. The eastern face of the configuration is what meteorologists call subsidence, the descending limb of the planetary atmospheric circulation, where the high-pressure system that anchors the central United States configuration extends an eastern flank that produces sinking air, clearing skies, suppressed convection, and very little measurable precipitation. The 7-day quantitative precipitation forecast through Sunday, June 7th, which is the operational forecast for cumulative rainfall across the continental United States for the next week, shows almost no measurable rain across most of New England, the mid-Atlantic, the Carolinas, and Virginia. And there is also very little to no rain expected west of the Rockies between now and Sunday. The wet axis is concentrated across the Great Plains and the upper Midwest, where several inches of rainfall are expected across most of the corridor through the period. That dry versus wet axis split is the surface signature of the Omega block configuration. The eastern flank produces subsidence and dry conditions. The central core produces persistent severe weather under the eastward extending ridge. The southern flank produces the heat dome. The western flank produces the cool Pacific cold aloft regime, and the boundary between the configuration and the Pacific Northwest trough produces the weekend transition. The New York City office of the National Weather Service, designated by the National Weather Service as the office at Upton, issued its area forecast discussion at 14:41 Universal Time this morning. The forecaster's 3 key messages were seasonable temperatures early this week with a chance for diurnal showers today and Tuesday, a moderate rip current risk continuing today, and summer heat building mid to late week. The Upton forecaster wrote that a mid-level shortwave pivoting through the region through early afternoon would bring partly to mostly cloudy skies with isolated to scattered showers, mainly from the New York City metropolitan area and to the north and west. Temperatures this afternoon were forecast to rise only to 65 to 70 across southern Connecticut and Long Island, and 70 to 75 from the New York City metropolitan area west, slightly below climatology. By midweek, surface high pressure was forecast to drop from Hudson Bay down into the Great Lakes as associated upper ridging merged with another upper ridge to the south over the plains. This ridge was forecast to gradually build eastward late this week, promoting rising temperatures. Areas from the New York City metropolitan area west were forecast to get back into the lower 80s on Wednesday, with more widespread 80s on Thursday. Daytime highs Friday and Saturday were forecast to approach or exceed 90, away from maritime influence, and could get close to daily record highs Thursday and Friday at Bridgeport, with some record high mins possible on Saturday in outlying areas. The Upton forecast trajectory is the operational fingerprint of the eastern face of the configuration. Cool and seasonable through midweek with the persistent eastern trough still in place. Then a ridge build eastward as the central ridge over the plains extends its eastern flank further east. Then 90-degree readings approaching or exceeding daily record highs by Friday and Saturday at Bridgeport. Record high minimum temperatures are the operational signature of overnight lows failing to drop the way they normally drop during the climatological diurnal cycle. The mechanism is the elevated dew point profile combined with the boundary layer mixing that the heat dome's eastern extension produces. The Mid-Atlantic Weather Prediction Center medium-range discussion confirmed the trajectory. The exact language was, temperatures will be average to above average over much of the eastern United States during the medium-range period due to troughing over the plains and ridging over the Midwest. Temperatures in the upper 80s to 90s, with overnight lows struggling to drop below 70 degrees, could lead to increased heat risk concerns along the mid-Atlantic coast this weekend. The Weather Prediction Center medium-range discussion specifically named the mid-Atlantic coast as the area of greatest weekend heat risk. The overnight lows failing to drop below 70 degrees is the operational threshold where heat-related illness becomes a public health concern. The combination of upper 80s to 90s daytime highs with overnight lows above 70 creates a sustained heat exposure that the human body cannot recover from during the climatological cooling overnight. The Mid-Atlantic coast weekend forecast is the operational signature of the Central Ridge, extending its eastern flank into the East Coast corridor and producing surface temperatures that approach the heat advisory threshold. The Boston office of the National Weather Service issued its area forecast discussion at 11:29 Universal Time this morning. The forecaster's two key messages were that isolated showers and cooler temperatures were expected today, that warmer temperatures with isolated showers or a stray storm were expected on Tuesday, and that forecast confidence decreases for late week. Conditions were more likely lean, dry and warm, but the forecaster continued to monitor the potential for an offshore system to bring showers. The Boston forecast confirms the eastern dry quiet through midweek with the late week ridge extension. The Philadelphia office of the National Weather Service issued its area forecast discussion at 10:55 Universal Time. The forecaster's two key messages were that a weak cold front would pass through the region early this morning, followed by a weak backdoor cold front later today. The second key message was that the forecaster was monitoring a far offshore low for midweek, but high pressure was expected to keep conditions dry through the end of the week. The Philadelphia forecast confirms the eastern dry quiet through the end of the week with high pressure as the dominant synoptic feature. The Baltimore-Washington office of the National Weather Service issued its area forecast discussion at 14:30 Universal Time. The forecaster's two key messages were that below normal temperatures continue through Wednesday with a chance of a mountain shower or thunderstorm Tuesday, and that more of a summertime pattern was forecast Thursday into the weekend as temperatures warm and thunderstorm chances increase. The Baltimore-Washington forecast confirms the eastern face trajectory, cool and dry through midweek under the trough, warmer with thunderstorm chances Thursday into the weekend as the Central Ridge extends eastward. The eastern dry quiet is the inverse of the central severe weather corridor. They are produced by the same configuration. The Central Ridge over the plains anchors the severe weather corridor on its western flank and produces the dry subsidence regime on its eastern flank. The same upper-level high-pressure system that is producing the 4,000 joule Cape air mass over central Alabama today is also producing the absence of measurable precipitation in the 7-day forecast for New York City, for Boston, for Philadelphia, for Washington, D.C. The two regional faces are not coincidentally simultaneous. They are two operational signatures of the same continental atmospheric configuration. The eastern face produces less news coverage because the absence of weather is harder to report on than the presence of weather. But the eastern face is going to determine an enormous fraction of the cumulative impact of the configuration on the country over the next 2 weeks. A 2-week period with no measurable rainfall across the entire East Coast corridor is the operational expression of a dry pattern that will compound on existing soil moisture profiles, on existing fire weather watches, on existing reservoir level concerns, and on the eastern flank of the same drought corridor that the V5 and V6 videos covered as the depleted landscape precondition for the southern plains heat dome amplification. The Pacific cold aloft regime over the west coast is the western flank of the configuration. The Los Angeles office of the National Weather Service issued its area forecast discussion at 1500 Universal Time this morning. The forecaster wrote, "Warm and dry conditions can be expected through most of this week, with coastal low clouds and fog at times." The short-term forecast noted that June arrives with its standard unexciting weather. At the upper levels there will be weak, saggy, broad troughing. Heights will be near 586 decameters, which is very close to normal. Onshore flow will prevail through the period, strongest to the east and in the afternoons. Maximum temperatures will fall across the coasts and valleys today and Tuesday as the onshore flow increases. Today's maximum temperatures will remain above normal, but Tuesday's cooling will bring most coast and valley maximum temperatures to a few degrees below normal. The long-term Los Angeles forecast noted that a weak ridge will nose in from the west on Thursday and Friday, with heights near 585 decameters. Heights will fall over the weekend as a trough originating from a decent-sized upper-low moves into the Pacific Northwest. Friday looks to be a day of June gloom due to the strong onshore flow both to the north and east. The ridge will bring some warming to the coasts on Thursday, but then the lowering heights and strong onshore flow will lead to 3 days of cooling Friday through Sunday. Weekend temperatures will be below normal across most coastal and valley locations. The Pacific cold aloft regime is the western flank of the same configuration. The Pacific upper low spinning over California and the Great Basin at 586 decameters is the operational descendant of the 555 decameter January comparable heights that the V9 video covered on May 27th. The configuration's western flank has weakened slightly relative to the May 27th state, but the cold aloft regime is still in place, the marine layer is still dominant, the onshore flow is still keeping coastal temperatures below normal. The Seattle office of the National Weather Service issued its area forecast discussion at 09:35 Universal Time this morning. The synopsis was specific. An upper-level ridge will build across the Pacific Northwest early this week, resulting in warming temperatures through Tuesday. Temperatures will peak on Tuesday, resulting in minor to moderate heat risk as well as much lower daytime relative humidity values. Onshore flow increases Wednesday as the upper ridge weakens. The next disturbance approaches western Washington later in the week. The warming trend peaks on Tuesday, with highs ranging from the upper 70s near the water to the mid to upper 80s through the interior. More inland locations may get close to 90. The Seattle pattern change on Wednesday is the operational signature of the configuration's western flank breakdown. The forecaster noted that the pattern changes on Wednesday as an upper-level shortwave trough, as well as a weak surface frontal system traverse the area. This system will bring in increased cloud cover, locally breezy conditions with stronger onshore flow, and much cooler temperatures with highs, returning into the low to mid-70s and 60s along the coast. The long-term Seattle forecast for Wednesday night through Sunday noted that latest ensemble guidance continues to consistently bring the next deeper upper-level trough into the region later in the week and into the weekend. This will maintain continued cooler and cloudier conditions, along with rain chances at times. The Pacific Northwest weekend transition is the operational signature of the deep upper-level trough that the Weather Prediction Center medium-range discussion identified as the dominant late-week feature for the Northwest. The Seattle Tuesday peak heat risk forecast, followed by the Wednesday cool-down, followed by the late-week deep trough arrival, is the operational fingerprint of the western flank of the central configuration, finally being broken by an incoming Gulf of Alaska trough that has been building over the Bering Sea for the last several days. And the Bering Sea storm complex active right now, with 3 concurrent storm warnings producing 50-knot winds and 23-foot seas across the Alaska Peninsula coastal waters, is the leading-edge signal of that incoming Pacific Northwest trough. The 2 regional features are the same atmospheric system in different stages of its life cycle. The Bering Sea-Alaska Peninsula storm complex is the Tuesday-Wednesday state of the trough. The Pacific Northwest weekend trough is the Friday-Saturday-Sunday state of the same trough as it translates southeastward toward the west coast of the contiguous United States. The same upper-level vortex that is producing the storm warnings off the coast of Kodiak Island today is the upper-level vortex that will produce the renewed precipitation chances in western Washington this weekend. The lower Matanuska Valley red flag warning at Palmer and Butte is the inland operational signature of the same system. The red flag warning was issued by the National Weather Service Anchorage office at 04:43 Alaska Daylight Time this morning. The warning was issued from 1 in the afternoon to 10 in the evening Alaska Daylight Time. The criteria were southeast winds up to 15 miles per hour, gusting as high as 20 to 30 miles per hour, relative humidity as low as 20 to 30%, temperatures as high as 65 degrees Fahrenheit. Location: lower Matanuska Valley, specifically around Palmer and Butte. Impacts: rapid ignition, growth, and spread of fires will be possible. The fire weather conditions in interior Alaska At the same time, the Bering Sea is producing 50-knot winds and 23-foot seas is the operational signature of the Alaska Peninsula and Bering Sea low-pressure system, having developed a sharp pressure gradient against the inland high-pressure ridge over interior Alaska. The pressure gradient is driving the offshore winds at the surface that are producing the storm-warning seas. The same pressure gradient is producing the warm, dry, down-sloping winds in the Matanuska Valley that are producing the fire weather conditions. The continental configuration is one system. The eastern dry quiet, the central severe weather corridor, the southern plains heat dome, the Pacific cold aloft regime over California, the Pacific Northwest weekend trough transition, and the Bering Sea Alaska Peninsula storm complex are all surface signatures of the same atmospheric configuration operating across the entire continent. The V9 video on May 27th named the configuration. The V12 video on May 30th tracked its 48-hour early verification. This video is tracking its 5-day verification and extending the analysis through the first 2 weeks of June into the question of whether the configuration extends past its forecast horizon and into the second half of June. The Pacific Northwest weekend trough is the first major synoptic feature that has the potential to begin to erode the central ridge from the west. As the trough translates southeastward across Washington and Oregon Friday into Saturday, the upper-level configuration over the western United States will become more amplified, the trough axis will deepen, and the cross-continent ridge that has been anchoring the configuration will be put under increasing pressure from the western flank. Whether the trough is energetic enough to push through the ridge and disrupt the configuration, or whether the trough is shallow enough that the ridge simply rebuilds behind it as the trough exits to the east, is one of the key uncertainties in the medium-range forecast. The Weather Prediction Center medium-range discussion identified this uncertainty explicitly. There is also some spread as to how the West Coast trough evolves this weekend, with the European and Canadian models developing a split flow pattern by next Sunday and Monday. The split flow scenario would mean the trough partially exits to the east, while another piece of upper-level energy lingers in the western United States, which would keep the western flank of the central ridge weakened, which would push the eastern face of the configuration even further east toward the mid-Atlantic, which would amplify the weekend heat risk forecast for the mid-Atlantic coast that the Weather Prediction Center medium-range discussion already named. The configuration is approaching its boundary condition test. The Pacific Northwest trough is the western boundary. The mid-Atlantic heat extension is the eastern boundary. The two boundaries are operating against the central ridge simultaneously from opposite sides, with the central ridge potentially extending eastward while also being eroded westward. The next several days will determine whether the central ridge is reinforced or weakened by the boundary condition interaction. The Climate Prediction Center, 6 to 10-day outlook and 8 to 14-day outlook, strongly suggest that the central ridge persists through the boundary condition test and continues to operate through the middle of June. The Weather Prediction Center medium-range discussion is convergent on the same conclusion. The Storm Prediction Center extended outlook supports continued multi-day severe weather risk across the central and northern plains through at least the end of the first full week of June. The forecast guidance, the climatological mechanism, and the historical analog distribution are all convergent on a multi-week persistence regime. The eastern dry quiet, the central severe weather siege, the southern plains heat dome, the Pacific Northwest weekend trough transition, and the Bering Sea storm complex are all operational signatures of the same configuration. The next two parts of this video walk through the global context, the Atlantic hurricane season opening quiet against the backdrop of the western Pacific producing super typhoon Sinlaku, and the continental scale implications of the configuration extending past its forecast horizon. The continental configuration is the system. The global context is the boundary conditions that constrain how the configuration develops over the next 2 weeks. Stay with me. We are about 3/4 of the way through the operational picture. Part 5. The Atlantic opens quiet, while the Pacific opens hot. The first day of meteorological summer is also the first day of the Atlantic hurricane season. The two seasons begin on the same calendar date by historical convention, and the National Hurricane Center has been issuing its formal tropical weather outlook products for the Atlantic Basin twice daily through the pre-season period and 4 times daily once the season formally opens. The outlook issued at 11:21 Universal Time this morning, signed by forecaster Berg, was unambiguous. The exact language was, for the North Atlantic, Caribbean Sea and the Gulf of America, Tropical cyclone formation is not expected during the next 7 days. Today marks the first day of the Atlantic hurricane season, which will run until November 30th. The long-term averages for the number of named storms, hurricanes and major hurricanes through the climatological peak are public, and the seasonal outlook for the entire year is now part of the operational record. The longer-range NOAA Atlantic hurricane season outlook for 2026 was released by the Climate Prediction Center in May. The outlook predicted a 35% chance of a near-normal season, a 10% chance of an above-normal season, and a 55% chance of a below-normal season. The forecast names a total of 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes, with 70% confidence in these ranges. For comparison, an average season has approximately 14 named storms with 7 hurricanes, including 3 major hurricanes. The agency's outlook explicitly identified the developing El Niño as the dominant factor driving the below-normal forecast, while noting that Atlantic SSTs are expected to be slightly warmer than normal, and trade winds are likely weaker than average. The competing factors are pulling the seasonal forecast in opposite directions, but the El Niño suppression is forecast to dominate, producing the below-normal season majority outcome. The opening of the season with zero tropical activity expected during the first 7 days is not anomalous against the climatological baseline. The historical average for the first week of June across the Atlantic basin is approximately 0 to 0.2 named storms. The historical first named storm before June, 15th probability is approximately 30%. The historical first named storm before July first probability is approximately 50%. The current zero formation outlook is consistent with a below-normal season forecast, consistent with the El Niño suppression signal, and consistent with the operational expectation that the first 30 days of the season will be quiet on the Atlantic side. The hype cycle that built up around a supposed early-season tropical storm named Arthur, which the V9 video covered as a category error and the V12 video covered as the V9 forecast verifying, is now formally closed. The National Hurricane Center's June 1st outlook is the closing of that hype cycle in the operational record. The forecast was right. The verification is in the public record. The other 2 basins that the National Hurricane Center monitors are showing similar patterns. The Eastern Pacific Tropical Weather Outlook issued at 11:23 Universal Time this morning noted that a broad area of low pressure located well southwest of the southern tip of the Baja California Peninsula continues to produce disorganized showers and thunderstorms. Environmental conditions were noted as marginally conducive. The Central Pacific Tropical Weather Outlook issued at the same time noted that tropical cyclone formation is not expected during the next 7 days, and that today marks the first day of the Central Pacific hurricane season, which will run until November 30th. The Eastern and Central Pacific basin openings are both consistent with the climatological baseline. The Eastern Pacific has marginal but not forming conditions southwest of Baja. The Central Pacific is empty. Now contrast the Atlantic basin opening quiet with what is happening in the Western Pacific basin at the same moment. The National Aeronautics and Space Administration's Earth Observatory feature for June 1st this year was a story on gravity waves observed from Super Typhoon Sinlaku. The exact language from the Earth Observatory feature, posted at 0401 Universal Time this morning, was, "Satellites observed striking upper atmosphere phenomena generated by an intensifying tropical cyclone. The fact that NASA's Earth Observatory has Super Typhoon Sinlaku as its featured story on the morning the Atlantic hurricane season opens with zero formation expected is the operational signature of the basin asymmetry that the El Niño teleconnection is producing. The Western Pacific Basin is producing super typhoons before the Atlantic Basin has produced its first named storm. The asymmetry is not coincidental. The asymmetry is the structural expression of the developing El Niño's effect on the global tropical activity distribution. The mechanism by which El Niño shifts the global tropical activity distribution is well established in the peer-reviewed climatological literature. The El Niño teleconnection produces increased upper tropospheric westerly winds across the tropical Atlantic, which increases vertical wind shear, which suppresses tropical cyclogenesis. The same teleconnection produces reduced upper tropospheric westerly winds across the Western Pacific Basin, which decreases vertical wind shear there, which allows the developing tropical disturbances to organize vertically, which supports tropical cyclogenesis. The mechanism is asymmetric across the 2 basins. El Niño suppresses Atlantic activity while enhancing Western Pacific activity. The basin asymmetry visible on the first day of meteorological summer 2026 is the operational expression of the same mechanism. The forward-looking implication for the Atlantic season is that the first 30 days are likely to remain quiet, with the next NOAA seasonal outlook update scheduled for early August before the climatological peak. The August update will be released against the backdrop of approximately 60 days of operational tropical activity data. If the first 60 days continue to be quiet, the August update will most likely keep the below-normal majority outcome in place. The El Niño suppression signal is forecast to strengthen through the summer, which means the suppression effect on the Atlantic basin is forecast to be larger in August and September than it is right now in early June. The May 28th Viv 10 video on this channel covered Typhoon number 6 of the 2026 Pacific typhoon season, which threatened Okinawa and southern Japan with violent winds during the same window that the May 27th forecast horizon began. The Western Pacific basin has now produced multiple early season systems, including at least one super typhoon and one major typhoon, against an Atlantic basin that has produced 0 named storms. The basin asymmetry is the operational expression of the El Niño teleconnection in the way that the climatological literature predicted. The continental United States is not directly exposed to Western Pacific tropical activity, which is the operational reason why the Atlantic basin opening quiet matters for the domestic weather story, while the Western Pacific basin opening hot matters more for the international weather story. But the basin asymmetry has a domestic implication that is worth flagging in the context of the multi-week continental configuration this video is built on. The El Niño teleconnection that is suppressing Atlantic tropical activity is the same El Niño teleconnection that is shifting the global hydrologic distribution. The Pacific cold aloft regime over the west coast that is keeping California cool, the building heat dome over the southern plains that is approaching 104 degrees in the Oklahoma Panhandle by next Wednesday, the Mid-Atlantic weekend heat risk forecast that the Weather Prediction Center medium-range discussion identified, and the Bering Sea storm complex active right now, are all operating against an El Niño developing backdrop that is the seasonal scale context for the configuration. The continental configuration is the synoptic scale expression. The El Niño teleconnection is the seasonal scale expression. The two are operating in the same atmospheric system simultaneously. The oceanic Niño index was at plus 0.11 degrees Celsius for the February-March, April 2026 season, having warmed steadily from minus 0.55 degrees Celsius for the October-November-December 2025 season. The agency's El Niño Watch issued in May identified an 82 to 98% probability of El Niño onset during the May-June-July season, and a 96% probability of persistence into the 2026 and 2027 winter. The China National Climate Center declared El Niño onset in April and May of 2026, forecasting a moderate intensity event peaking with sea surface temperature anomaly of plus 2.0 to plus 2.5 degrees Celsius. The El Niño event is real. The forecast for it is operational. The V2 video on this channel covered the El Niño southern oscillation mechanics in depth, including the Walker circulation, the thermocline, the Kelvin waves, the Bjerknes feedback, and the historical super El Niño analog cases. The current El Niño event is not yet at the strength of the historical super El Niño analogues. The forecast places it in the moderate intensity range with the peak sea surface temperature anomaly forecast at plus 2.0 to plus 2.5 degrees Celsius by winter 2026 and 2027. That places it as a moderate to strong event but not in the super El Niño range. The operational implication of the moderate to strong El Niño forecast for the Atlantic hurricane season is that the suppression effect on the basin will be substantial but not extreme. The Atlantic basin during moderate El Niño years has produced near normal to below normal seasons, with named storm counts in the 8 to 15 range. The current NOAA forecast of 8 to 14 named storms with 3 to 6 hurricanes is consistent with a moderate El Niño year. The historical analog distribution supports the forecast. The forward-looking question for the Atlantic season is what the August update will say. The August update will be released before the climatological peak of the season, which historically runs from late August through early October. The August update will incorporate approximately 60 days of operational tropical activity data, an updated reading of the El Niño southern oscillation state, and an updated assessment of the Atlantic basin sea surface temperature anomaly. If the first 60 days of the season continue to be quiet, the August update will most likely confirm the below normal majority outcome and may push the forecast slightly toward the below normal extreme. If the first 60 days of the season produce one or two early season Atlantic systems despite the El Niño suppression, The August update may revise the forecast toward the near-normal majority outcome. The base case is the below-normal outcome. The forecast for it has been published. The next update will be in early August. The basin asymmetry that the Atlantic opening quiet against Sinlaku demonstrates this morning is also relevant to the continental configuration that this video is built on. The El Niño teleconnection produces some atmospheric pattern shifts that affect the continental United States. The southward shift of the subtropical jet stream across the southern United States during El Niño years is the operational mechanism that drives the increased winter precipitation across California and the desert southwest. The same southward jet stream shift produces below-normal Atlantic hurricane activity through the increased upper-level westerly winds across the basin. And the same southward jet stream shift produces some effects on the summer continental atmospheric circulation through the modulation of the subtropical ridge axis. The current configuration over the central United States is not directly caused by the El Niño event. The configuration is the synoptic scale expression of the May 27th atmospheric state, driven by the planetary wave packets that the V9 video covered. But the El Niño backdrop is the seasonal scale modulation that is providing the boundary conditions for the configuration. The Southern Plains heat dome forecast for next week, the Mid-Atlantic weekend heat risk forecast, and the Atlantic basin quiet opening are all operating against the same El Niño teleconnection backdrop. The continental configuration is the system. The El Niño teleconnection is the boundary condition. The basin asymmetry between the Atlantic opening quiet and the Western Pacific producing super typhoon Sinlaku is the global scale signature of the boundary condition operating across the entire northern hemisphere. The first 30 days of the Atlantic hurricane season are likely to remain quiet. The next major Atlantic forecast update will be in early August. The August update will determine whether the seasonal trajectory continues toward the below-normal majority outcome, or whether the seasonal trajectory shifts toward the near-normal alternative. The Atlantic basin opening quiet is the first piece of evidence that the El Niño teleconnection is operating in the way the climatological literature predicts. The continental configuration over the central United States is the operational outcome of the synoptic scale atmospheric state for the next 2 weeks. The continental configuration is going to deliver severe weather across the central and northern plains, heat across the southern plains, dry quiet across the east coast, and the Pacific Northwest weekend trough transition. The Atlantic basin is going to remain quiet through at least the first 30 days of the season. The basin asymmetry between Atlantic quiet and Western Pacific hot is the El Niño signature. We have now walked through the central and northern plains severe weather corridor for the next 3 days. We have walked through the heat dome trajectory for the southern plains through next week. We have walked through the eastern dry quiet across New England and the mid-Atlantic. We have walked through the Pacific Northwest weekend trough transition and the Bering Sea-Alaska Peninsula storm complex. We have walked through the Atlantic basin opening quiet against the Western Pacific basin producing super typhoon Sinlaku. The next part of this video walks through the Alaska signal in detail, because the Alaska signal is the leading-edge synoptic feature that will most directly affect the breakdown trajectory of the central configuration over the next several days. And then the final part of this video walks through the question of when the central ridge breaks down, and what happens to the country during the next 2 weeks if the ridge holds further than its forecast horizon. The continental configuration is one system. The next 2 parts of this video walk through the boundary conditions and the breakdown timing. Stay with me. Part 6. The Alaska signal and the continental configuration. The state of Alaska is currently producing one of the most operationally informative weather signals in the entire northern hemisphere, and the signal is worth walking through carefully because it is the leading-edge synoptic feature that will most directly affect the breakdown trajectory of the central configuration over the next several days. There are at this hour 3 concurrent storm warnings active across the Alaska Peninsula coastal waters. There is a companion flood watch active for Kodiak Island. There is a red flag warning for fire weather active in the lower Matanuska Valley around Palmer and Butte. The fact that 3 completely different hazard types are operationally active in the same state on the same morning is the surface signature of a sharp synoptic gradient operating across the state, which is itself the leading-edge expression of the deep upper-level trough that the Weather Prediction Center medium-range discussion has flagged as the dominant late-week feature for the Pacific Northwest. The 3 storm warnings were issued by the National Weather Service Anchorage Office at 3:48 Alaska Daylight Time this morning. They cover the Alaska Peninsula coastal waters from Castle Cape to Cape Tolstoy, and from Sitkinak to Castle Cape. The forecast for the coastal waters is northeast winds at 50 knots with seas at 23 feet and rain. All three warnings are valid until 5 in the afternoon, Alaska Daylight Time today. 50-knot winds are equivalent to approximately 58 miles per hour. The operational threshold for the storm warning classification at the National Weather Service Marine Forecast Desk is 48 knots, or 55 miles per hour. The storm warning classification is one level below the hurricane force wind warning, which begins at 64 knots, or 74 miles per hour. The conditions in the Alaska Peninsula coastal waters today are equivalent to what a strong nor'easter would produce off the New England coast. The conditions are unusual for early June in the Bering Sea, where the climatological wind speeds are typically in the 20 to 30 knot range, and the climatological sea heights are typically in the 8 to 12 foot range. The Kodiak Island Flood Watch was issued by the National Weather Service Anchorage Office at 11:49 Alaska Daylight Time on May 31st. The flood watch covers Kodiak Island northeast and Kodiak Island southwest, including the cities of Kodiak City, Port Lions, Uzinki, and Old Harbor. The flood watch is valid from Monday morning through Wednesday morning local time. The hazard description is excessive runoff from heavy rain may result in flooding of rivers, creeks, streams, and other low-lying and flood-prone locations. The mechanism is the persistent rainfall associated with the same storm warning system that is producing the 50-knot winds. The rainfall forecast for Kodiak Island over the next 48 to 72 hours is in the range that historically produces low elevation flooding. The red flag warning was issued by the National Weather Service Anchorage Office at 4:43 Alaska Daylight Time this morning. The warning is valid from 1 in the afternoon to 10 in the evening Alaska Daylight Time today. The hazards are southeast winds up to 15 miles per hour gusting as high as 20 to 30 miles per hour, relative humidity as low as 20 to 30%, temperatures as high as 65 degrees Fahrenheit, and the operational impact statement is that rapid ignition, growth and spread of fires will be possible. The location is the lower Matanuska Valley, specifically around Palmer and Butte. The Matanuska Valley is the inland agricultural corridor northeast of Anchorage in the Susitna Valley region that drains into Cook Inlet. The fire weather conditions in interior Alaska on the same morning that the Bering Sea is producing 50-knot winds and 23-foot seas is the operational signature of the pressure gradient between the offshore low-pressure system and the inland high-pressure ridge. The mechanism that produces the simultaneous storm and fire weather is straightforward. The offshore low-pressure system that is producing the storm warnings in the Bering Sea has a sharp pressure gradient against the inland high-pressure ridge over interior Alaska. The pressure gradient drives the northeast winds at the surface in the coastal waters, which produces the storm warning conditions. The same pressure gradient drives compensating winds across the Matanuska Valley from the southeast, which produces the downsloping wind component that lowers the relative humidity and raises the temperature. The downsloping winds across the Matanuska Valley are the inland operational signature of the offshore pressure gradient that is producing the marine storm conditions. The two regional outcomes are not coincidentally simultaneous. They are the two sides of the same pressure gradient operating across the state. The continental implication of the Alaska signal is that the upper-level low-pressure system that is anchoring the offshore storm warning conditions is the same upper-level low-pressure system that is forecast to translate southeastward across the next several days into the Pacific Northwest. The Weather Prediction Center medium-range discussion identified this trajectory explicitly. A deep upper-level trough will bring renewed precipitation chances to the northwest this weekend. The trough is the same upper-level vortex that is currently producing the storm warnings in the Alaska Peninsula coastal waters. The trough is expected to deepen as it translates southeastward, drawing energy from the cold aloft regime that has been parked over the Pacific Northwest for the last week, and arriving in western Washington with sufficient amplitude to produce the renewed precipitation chances that the Seattle area forecast discussion identified for Friday into Saturday. The Bering Sea-Alaska Peninsula Storm Complex is the leading-edge signal of the Pacific Northwest weekend trough. The two regional features are the same atmospheric system in different stages of its life cycle. The Bering Sea storm is the Tuesday-Wednesday state of the trough as it sits over the Bering Sea and produces the offshore storm warning conditions. The Pacific Northwest weekend trough is the Friday-Saturday-Sunday state of the same trough as it translates southeastward across the Gulf of Alaska and arrives in western Washington. The intervening 12 to 72 hours are the period during which the trough translates from its current Bering Sea position to its forecast Pacific Northwest position. The Seattle Tuesday peak heat risk forecast, with possible 90-degree readings in the South Sound region, is the operational signature of the upper-level ridge that the trough is about to displace from the Pacific Northwest. The Wednesday cool-down, with highs returning to the low to mid-70s and 60s along the coast, is the operational signature of the trough beginning to translate into the region. The Friday and Saturday continued cooler and cloudier conditions are the operational signature of the trough fully arriving and producing renewed precipitation chances. The implication of the Alaska signal for the continental configuration is that the Pacific Northwest weekend trough is the first major synoptic feature that has the potential to begin to erode the central ridge from the west. The trough will arrive in western Washington Friday into Saturday. The trough will then translate eastward across the northern tier of the country through the weekend, potentially crossing into the northern plains by Monday, June 8th or Tuesday, June 9th. The northern plains location of the trough by next Monday or Tuesday is the same geographic corridor where the Climate Prediction Center 6 to 10 day outlook identifies elevated probability of extreme heat through the middle of June. The interaction between the incoming trough and the central ridge is the boundary condition test for whether the configuration extends past its forecast horizon. If the trough is energetic enough to push through the ridge and disrupt the configuration, the central United States will see precipitation return to the corridor by approximately June 9th or June 10th, and the heat dome over the southern plains will lose its upper-level anchor and weaken. If the trough is shallow enough that the ridge simply rebuilds behind it as the trough exits to the east, the configuration will continue to operate through the second week of June, with the heat dome continuing to compound over the southern plains and the rapid onset drought watch that the Climate Prediction Center has issued for the same window continuing to be the operational expectation. The Weather Prediction Center medium-range discussion identified this uncertainty explicitly. The exact language was, "There is also some spread as to how the West Coast trough evolves this weekend, with the European and Canadian models developing a split flow pattern by next Sunday and Monday." A split flow scenario would mean the trough partially exits to the east, while another piece of upper-level energy lingers in the western United States, which would keep the western flank of the central ridge weakened, which would push the eastern face of the configuration even further east toward the mid-Atlantic, which would amplify the weekend heat risk forecast that the Weather Prediction Center medium-range discussion already named. The split flow scenario is the most likely outcome based on the current ensemble guidance. The configuration is approaching its boundary condition test. The Pacific Northwest trough is the western boundary. The mid-Atlantic heat extension is the eastern boundary. The configuration is being squeezed between the two boundary conditions, but the central ridge is forecast to hold through the boundary condition test. The Climate Prediction Center 6 to 10 day and 8 to 14 day outlooks support the configuration holding through the test. The Weather Prediction Center medium-range discussion is convergent on the same conclusion. The Storm Prediction Center extended outlook supports continued multi-day severe weather risk across the central and northern plains through at least the end of the first full week of June. The Denver area forecast discussion's 5 consecutive day surface-based Cape forecast supports continued severe weather potential through Friday. The Bismarck hazardous weather outlook supports the Tuesday slight risk and the continued severe weather corridor through Wednesday. The Houston and Dallas-Fort Worth area forecast discussions support continued heat through midweek. The New York City, Boston, Philadelphia, and Baltimore, Washington area forecast discussions all support continued eastern dry quiet through midweek, with the ridge extension producing increased heat risk by the weekend. The forecast guidance is convergent across the entire forecast hierarchy on the configuration holding through the boundary condition test and continuing to operate through at least the middle of June. The Alaska signal is the leading-edge synoptic feature that will most directly affect the boundary condition test. The Bering Sea storm warnings are the operational signature of the trough that is approaching from the Pacific. The Kodiak flood watch is the operational signature of the rainfall that the trough is producing in its current Bering Sea position. The lower Matanuska Valley red flag warning is the inland operational signature of the pressure gradient that the offshore low-pressure system is producing against the inland high-pressure ridge. All 3 regional outcomes are operationally connected to the same upper-level synoptic feature. The same feature is forecast to arrive in the Pacific Northwest by Friday or Saturday. The arrival of the trough in the Pacific Northwest is the first major synoptic event in the next 2 weeks that has the potential to begin to disrupt the central configuration. The forecast guidance suggests the disruption will be partial. The configuration is forecast to continue operating through the disruption. The boundary condition test is forecast to be passed. The Alaska signal also has secondary implications for the continental configuration that are worth noting. The Tuesday and Wednesday forecast for the Alaska Peninsula coastal waters has the winds shifting from northeast to southwest as the upper-level low-pressure system translates eastward. The forecast Bering Sea conditions for Wednesday afternoon are northeast winds at 50 knots, with seas at 23 feet, the same conditions that are currently in effect, indicating that another piece of upper-level energy may be moving into the same geographic corridor as the first trough exits. The persistence of the storm warning conditions in the Bering Sea across multiple synoptic scale features is the operational signature of an active North Pacific jet stream regime. The active regime is one of the contributing factors to the Pacific cold aloft regime that the V9 video covered as the western face of the Omega Block configuration. The lower Matanuska Valley red flag warning is the inland operational signature of the pressure gradient. The warning is valid only for today and is not extended into Tuesday or Wednesday, which suggests that the inland fire weather conditions are forecast to weaken after today as the offshore pressure gradient relaxes. The Kodiak flood watch is valid from Monday morning through Wednesday morning local time, which is the operational forecast window for the rainfall associated with the first upper-level low-pressure system. The watch is not extended into Thursday or Friday, which suggests that the rainfall is forecast to taper after Wednesday morning as the first upper-level low-pressure system passes through. The Alaska signal is the leading-edge signal of the Pacific Northwest weekend trough. The trough is the first major synoptic event in the next 2 weeks that has the potential to begin to disrupt the central configuration. The forecast guidance suggests the disruption will be partial, the configuration will continue to operate, and the heat and severe weather siege over the central United States will continue to compound through the middle of June. The next part of this video walks through the question of when the central ridge ultimately breaks down, what the historical analog distribution suggests about the breakdown timing, and what the country can expect during the period between now and the breakdown. The continental configuration is going to be tested by the Pacific Northwest weekend trough. The continental configuration is forecast to pass the test. The continental configuration is forecast to continue operating through the second week of June and possibly extend into the third week. The breakdown timing is the single most consequential forecast variable for the rest of the month. The next part walks through it. The 3 readings of the configuration, the most defensible reading, the historical analog distribution, and the question of what the country looks like by the time we get to the end of June. Stay with me. The final part of the video lands the central thread on the binary that the rest of the month will resolve. Part 7. When does the ridge break down? We have walked through every face of the configuration. The central and northern plains severe weather siege happening right now, the heat dome building toward 104 degrees in the Oklahoma Panhandle by next Wednesday, the eastern dry quiet across New England and the mid-Atlantic, the Pacific cold aloft regime over California that is finally being broken by the Pacific Northwest weekend trough, the Bering Sea storm complex that is the leading-edge signal of that trough, the lower Matanuska Valley fire weather conditions that are the inland operational signature of the same pressure gradient, the Atlantic hurricane season opening quiet against the western Pacific producing super typhoon Sinlaku, and the climatological mechanism that ties all of those regional outcomes back to a single, high-amplitude blocking configuration over central North America. The configuration is the system. The boundary conditions are the constraints. The forecast verified. The verification is in the operational record. The next 2 weeks are going to deliver active weather across the central United States, heat over the southern plains, dry quiet across the East Coast, and the Pacific Northwest weekend transition. The country is now inside the multi-day operational window where the forecast extends. But the verification is not the end of the story. The question that the rest of the month will answer is when the central ridge breaks down, what the historical analog distribution suggests about the breakdown timing, and what the country looks like by the time we get to the end of June. The answer to the breakdown timing question is the single most consequential forecast variable for the rest of meteorological summer. There are 3 ways of reading the configuration that we have now walked through. The first reading is that the configuration is a routine multi-day continental severe weather siege under a high-amplitude blocking ridge. The pattern is in the upper decile of climatological June severity, but inside the historical range. The drought signature, the heat, the eastern dry quiet, the Pacific cold aloft regime, and the central severe weather corridor are the standard regional faces of a strong Omega block configuration. The configuration will break down within the next 14 to 21 days per the historical analog persistence distribution. The first reading frames the configuration as serious but inside the climatological range. The second reading is that the configuration is the operational verification of a forecast that this channel published on May 27th, that has now been confirmed at the 5-day verification mark across every regional face the forecast named, that the Climate Prediction Centre has confirmed will extend through at least mid-June, with the 8 to 14-day extreme heat outlook and the rapid onset drought watch, that the Weather Prediction Centre has confirmed will extend through at least the first full week of June, with the medium-range multi-day marginal risk corridor, that the regional National Weather Service offices have confirmed with the multi-day 1500 to 2000 joules surface-based Cape corridor across the central high plains, and that the historical analog persistence distribution suggests will most likely hold through the first 2 weeks of June and may extend into the second half. The second reading frames the configuration as forecast resolved and operationally locked in, with elevated prior probability for the next phase being the continuation of the configuration through at least the middle of June. The third reading is that the configuration is the operational expression of a climate-amplified continental mode. Arctic amplification is slowing the jet stream. Low phase speed Rossby wave packets are driving shortwave vortex trains across the central plains. Quasi-resonant amplification is locking the blocking configuration into place. Soil moisture feedback is amplifying surface temperatures over a depleted soil landscape. An El Niño backdrop is shifting the global hydrologic distribution. The third reading frames the configuration as a climatological expression of a system that, on average, produces blocks that hold longer than they used to, on landscapes that respond more sensitively to heat than they used to, against an oceanic background that has been shifting for at least 3 years. The configuration is individual, the climatology is general, and the third reading insists that the distinction matters without losing sight of the individual event in front of us. The most defensible reading lies in the middle. The pattern is real, the forecast was right, the multi-week persistence is likely but not guaranteed, the climate background that makes patterns like this more persistent is also real, but does not predict any individual realization. The country has the forecasts, the country has the alerts. The question over the next 2 weeks is whether the country reads them. The historical analog distribution for blocking configurations in this class is the operational reference for the breakdown timing question. The 2003 European heatwaves blocking high persisted for approximately 20 days. The 2010 Russian heatwaves blocking high persisted for approximately 35 days. The 2021 Pacific Northwest heat domes blocking ridge persisted for approximately 14 days at peak amplitude. The 2022 European heatwaves blocking configuration persisted for approximately 18 days. The mean persistence of these analog configurations is approximately 22 days. The standard deviation is approximately 8 days. The May 27th forecast horizon for the configuration was the first 2 weeks of June, which corresponds to a 14-day persistence window. The 14-day forecast horizon is 1 standard deviation below the analog mean of 22 days. The historical analog mean places the breakdown window around June 18th. The historical analog 1 standard deviation range places the breakdown window from June 10th to June 26th. The configuration is now inside the window, where the breakdown decision is the dominant forecast variable for the rest of the month. The single most consequential forecast variable for the second half of June is the breakdown timing of the central ridge. If the ridge breaks down between June 8th and June 12th, the second half of June will likely transition to a more zonal jet stream regime with normal climatological severe weather distribution, and the central conus heat dome will lose its anchor and weaken. The country will exit the first half of June with a serious but inside the historical range severe weather siege that fades from memory by the start of July. If the ridge holds through June 15th or June 18th, the cumulative heat impact in the southern plains will compound past the V9 video's 2-week forecast horizon. The rapid onset drought that the Climate Prediction Centre has flagged will likely materialise across portions of the central United States, and the soil moisture feedback will amplify the heat further into the climatological warm season. The country will exit the 3rd week of June with a multi-week continental event in the upper decile of historical analogue severity, requiring sustained heat emergency response across the southern plains and possibly the mid-Atlantic. If the ridge holds past June 20th, the configuration enters the territory typically reserved for the most analogous historical heatwave events, the 2010 Russian heatwave being the upper bound reference case, and the second half of June begins to look like a continental heatwave event in the same statistical class as the most persistent historical analogues. The configuration would then be remembered, the way the climatological literature remembers 2010 Russia. The forecast guidance is convergent on the configuration holding through at least mid-June. The Climate Prediction Center, 6 to 10 day and 8 to 14 day outlooks support persistence through June 15th. The Weather Prediction Center medium-range discussion supports persistence through at least the first full week of June. The Storm Prediction Center extended outlook supports persistence of the severe weather corridor through at least the end of the first full week. The Denver Area Forecast Discussion's 5 consecutive day surface-based Cape forecast supports persistence through Friday. The historical analog distribution centered on a 22-day mean places the breakdown window most likely between June 18th and June 23rd. The forecast guidance and the historical analog distribution are both pointing toward the configuration holding through approximately the second week of June and breaking down sometime in the third week. The question that the rest of June will answer is whether the breakdown occurs at the lower bound of the analog distribution or the upper bound. The lower bound places the breakdown around June 10th, which would mean the configuration ends earlier than the forecast horizon, and the country exits the first half of June with a more modest severe weather and heat impact than the forecast suggests. The mean places the breakdown around June 18th, which would mean the configuration extends approximately 4 days past the V9 video's forecast horizon, and the country experiences the heat dome trajectory through next week, and the rapid onset drought through the following week. The upper bound places the breakdown around June 25th or June 26th, which would mean the configuration extends a full 11 days past the V9 video's forecast horizon, and the country experiences a multi-week continental event in the same statistical class as the 2010 Russian heatwave. The most defensible reading is the middle of the distribution. The forecast for the configuration to hold through the second week of June is supported by every layer of the forecast hierarchy. The forecast for the configuration to break down by approximately June 18th or June 20th is supported by the historical analog mean. The probability of the configuration holding past the upper bound of the distribution is non-zero, but lower than the probability of the configuration breaking down inside the mean +1 standard deviation range. The most likely outcome for the rest of meteorological June is that the configuration holds through at least June 15th, possibly through June 20th, and then breaks down inside the third week with the country transitioning to a more zonal regime by the start of July. But the most likely outcome is not the only outcome. The 8-day standard deviation of the historical analog distribution is wide enough to include both the lower bound scenario, where the configuration breaks down by June 10th, and the upper bound scenario, where the configuration extends past June 25th. The Climate Prediction Center has already issued the rapid onset drought watch for the central United States through mid-June. The Weather Prediction Center has already flagged the mid-Atlantic weekend heat risk for the coming weekend. The Storm Prediction Center has multi-day severe weather corridors active right now. The country is operating under the forecast guidance that the configuration holds through at least mid-June. The country is approaching the window where the breakdown timing becomes the dominant forecast variable for the rest of the month. What is going to happen over the next 14 days is a multi-week severe weather siege across the central and northern plains, a building heat dome across the southern plains that will reach triple-digit values by the middle of next week, a continued eastern dry quiet across New England and the mid-Atlantic, with the ridge extension producing increased heat risk by the weekend, the Pacific Northwest weekend trough transition, and the Atlantic hurricane season remaining quiet against the El Niño suppression backdrop. The forecast for all of these regional outcomes is operational. The configuration is going to deliver. What is going to happen after the next 14 days depends on the breakdown timing. The most likely outcome is that the configuration holds through mid-June and breaks down in the third week. The heat dome reaches its peak intensity around June 10th or June 11th in the southern plains. The rapid onset drought watch materializes across portions of the central United States. The mid-Atlantic experiences a weekend of upper 80s to 90s, with overnight lows above 70. The Pacific Northwest gets renewed precipitation by the weekend. The Atlantic basin remains quiet. The second week of June extends the configuration into a multi-week regime that the climatological literature will remember as one of the persistent block events of the post-2020 period. The less likely outcome is that the configuration extends past the upper bound of the historical analog distribution. The configuration would then enter the territory typically reserved for the most analogous historical heatwave events. The country would exit the third week of June with a multi-week continental event in the upper decile of historical severity. The climate-amplified continental mode reading would gain support from the operational outcome. The configuration would be remembered. But that is not the most likely outcome. The most likely outcome is the middle of the distribution. The forecast guidance supports persistence through at least mid-June and breakdown in the third week. The historical analogue mean places the breakdown around June 18th. The most defensible reading is the middle. The country is now inside the window where the breakdown decision is the dominant forecast variable for the rest of the month. The forecast for the next 14 days is operational across every layer of the hierarchy. The verification of the V9 forecast is in the operational record. The continuation of the configuration through at least mid-June is forecast across every layer. The breakdown timing is the question that the rest of June will answer. The country has the forecasts. The country has the alerts. The country has the institutional response framework. The question over the next 14 days is whether the country reads them, prepares for them, and acts on them. This is the continental configuration. This is the multi-week severe weather siege. This is the first 2 weeks of meteorological summer. The May 27th forecast was right. The verification is in the operational record. The next 14 days are going to deliver. And the breakdown of the configuration is the single binary that determines whether the rest of June fades from memory or whether the rest of June joins the climatological list of patterns that the literature remembers by name. Stay with the forecasts. Stay with the alerts. The next 2 weeks are going to be one of the most active stretches of weather the continental United States has seen this year. The forecast verified 5 days ago. The forecast for the next 14 days is operational across every layer. The country is now inside the window where what happens over the next 2 weeks will determine whether June is remembered as a serious but routine severe weather siege, or whether June is remembered as the first multi-week continental event of summer 2026. The forecast is right. The configuration is operational. The next 14 days are going to deliver, and the breakdown decision is the single binary that the rest of the month will resolve.